So I'm Avas and I'll be presenting our foundational model for agriculture. So we know that foundational models have immense success in recent times, from ChatGPT to recent DeepSeek and Quinn-like models that work really well across modalities and have really good understanding capabilities. But these models often fail on more specialized areas. And one of the area that they really fail in is agriculture. And the main issue is the fine-grained knowledge in agriculture that usually is not present in an accessible form on the internet that these models can consume. So for instance, certain diseases in agriculture, they might have very similar features. The features may appear very similarly across different diseases, so models tend to confuse these diseases and they would offer help that probably is not very useful. So, to solve this challenge, we created this foundational model for agriculture. But one of the major issue in these sort of area is the lack of data. So, in order for us to train a more effective model, we need text and vision data. So there should be interleaved text and image data for the task at hand. And in agriculture, you can find lots of data sets that are image only, but there's not many data sets that have both image and text interleaved with each other. So to solve this issue, we first created a method to use the image-based data and gathered the contextual information around these image-based data sets. And then we created agro-instruct, which is the instruction tuning data set. And then we trained fine-tuned models on these agro-instruct data set. Okay, so as I mentioned, there are plenty of image-only data sets that are available on the internet, but unfortunately these data sets didn't have as much information, metadata that we would like to have in order to train a foundational model. So to circumvent that, we collaborated with an expert in agriculture, and we created we collected contextual information around these image-based data sets. So for instance, this contextual information would mean that the disease information related to disease, what sort of symptoms are present when this disease appears in a certain plant, and similarly, what sort of cures are available in order to solve this problem. So we created this contextual information with the help of an agricultural expert, and then we, using both image and the textual data, we then used a simple language model to create instruction following sort of data set. So what this does is this takes this raw text and image data and then creates information that is more accessible for the downstream model. So this means that we get image description, we get external knowledge and context example, stuff like that, and then we created this agro-instruct based on that. So the second phase, after the main challenge obviously is the data set here, right? So the second challenge was fine-tuning. So for that we introduced what we call expert tuning. So the main aim of this expert tuning is to instill this fine-grained expert knowledge into generalized foundational models. So we achieved significantly better performance compared with the specialized model. So if you see blue line is our model, and the other baseline, the red line is baseline. So these would be ChatGPT like models. So our model significantly outperforms both in question answer data sets as well as in human evolves, which were done using an agricultural expert. Thank you very much.